So another way to deal with confounding variables is to adjust them in your statistical analysis. So suppose we have the following scenario. We have an exposure group and a group that's unexposed. Okay, so we can also call this the treatment group if it's an intervention study or an RCT, and the control group. And so we have our exposure confounded with age in this study. So we have, in this case, 80% of the people are young and only 20% are old. And in the other case, we have 80% are old and only 20% are young. And let's say also that we know that the event rates differ for old and young. So for old, the event rate is 20.2, and for young, the event rate is 0.1. So now we're going to calculate both the unadjusted and the adjusted relative risk. So first, let's calculate the unadjusted risk. So we want to calculate the event rate in each group, in the treatment and the control. So we know that we have 100 people in each group, and we know that in the treatment group we have 80% of those 100 are young. So to calculate the event rate in the treatment group, we want to take into account the fact that the event rates are different for old and young, and the proportion of individuals in that group who are old and young. So we know that we have 80, so 80% of 100, young participants, and the rate in the young is 10%, or 0.10. So we're going to take the 80 and multiply it by 0.1 to get that part of the event rate, and then we're going to add the event rate in the 20% of participants who are old. So we've got 20 old participants times their event rate of 20%, and so that equals a total event rate in the treatment group of 12. So it's 8 events in the young and then 4 events in the old equals a total of 12 events. So we'll put 12 events over here, so we know there's a total of 100, so the number of events is 12, or number of people with events in this case, and so the number of non-events, the number of people who did not have an event, is 88. And now we'll just do the same thing for the control group. So we have, in this case, 20% of the participants in the control group are young, so 20 out of 100, 20% of 100 is 20, times their event rate, which is 0.1, so that's 2 events for the young, plus 80 old people times their event rate of 20%, which equals 16 events for old people, so that's a total of 18 events in the control group. And so then we want to calculate the relative risk for the treatment versus control, and we do that by taking the event rate, the incidence, in the treatment group, which in this case is 12 out of 100, so 0.12, over the incidence in the control group, or the unexposed, is 18, so 0.12 over 0.18 equals 0.67, so there's a relative risk of 0.67. So the treatment is protective, in this case, against the event. And so we have a relative risk of 0.67 here, but we have not yet adjusted for the difference between old and young. So this relative risk difference could be due to the fact that in the treatment group there are so many more young people and their event rate is lower. So this lower event rate in the treatment group may be just due to the fact that there are a greater number of young people in the treatment group relative to the control group. So how do we account for that difference? So to adjust for confounding variables, you need to calculate the relative risk separately for each level of the variable. So for the treatment group, we have a total of 80 young participants times their event rate, which is 0.10. So that's 8 events in the treatment group. And then in the control group, we have 20 people and an event rate again of 10%. So that's 2 events in the control group. So when we go over to the table, we have 8 events in the treatment group and a total of 80 people. So the incidence rate in the treatment group is 8 out of 80, or 10%. And then for the control group, there are 2 events out of 20, which is also an event rate of 10%. So we have an incidence of 10% in the treatment group and 10% in the control group, so the relative risk in the young is 0.1 over 0.1, which equals 1. And so now let's calculate the relative risk in the old. So for the old population, the old subset of the population, we have 20 people in the exposed group times an event rate of 20%, which equals 4 events. So we'll put the 4 over here, and there's a 20 total in that group. And then for the control group, we have a total of 80 people in the control group, 80 older people, times the event rate of 20% equals 16 events. So 16 can go here out of 80. So now we can calculate the relative risk by calculating the incidence in the treatment and the incidence in the control. So we calculated the incidence in the treatment group, 4 out of 20, or 20%, and the incidence in the control group, 16 out of 80, equals 20%. Then the relative risk among the old only is 0.2 over 0.2, or 1. So what this shows is that we calculated the relative risk separately for the different levels of the confounding variable and found that there is no effect of the treatment in the young because there was a relative risk of 1, and there was no effect of the treatment in the old. There's a relative risk of 1. And so that tells us that the original unadjusted relative risk that we saw before, which was 0.67, was due to the confounding variable of age. So I apologize for the extremely busy slide here, but in general, this just shows you how confounding variables can be adjusted for in statistical analysis. Now, this is just a schematic example. I'm not telling you how they put together these different relative risks that are associated across different levels, because we don't want to get into too much math, but that's basically what happens when you're adjusting for confounding variables. You're looking at the effect separately in each level of confounding variables, and so that's how adjustment can take into account confounding variables. And so when you see an unadjusted relative risk or an unadjusted measure of any kind, you know that there has been no adjustment for confounding variables. So that's why you can get a big difference between an unadjusted and an adjusted outcome. And so that's it. Hopefully that will help you understand adjustment a little bit better.